everyone. Hello. Good morning, good afternoon, and good night to the developers all over the world. Welcome to this workshop. And maybe wait for like 1 or 2 more minutes. Hi, Jan. Welcome. Can you type the city or countries you are living? Okay, hello everyone. Yeah, for now it's already 10 p.m. and 2 and in my time zone, so it's 10 p.m. for me. I hope the time is good for you. And yeah, Prague, a nice city. Yeah, nice city. I love it. Yeah, I hope this timing is good for you. And I'm in the 10 p.m. Yeah. Hi, Enoch. Hello, Enoch. Yeah, maybe let's just start. So first of all, welcome everyone. Welcome all the developers all over the world come to this workshop during the Chainlink Spring Hackathon. And today we are going to talk about something exciting, the CCIP, the Cross-Chain Interoperability Protocol, which is a service provided by Chainlink Labs to allow developers to cross your message or tokens from the source chain to destination chain. And in this workshop, we will talk more about CCIP. We will dive into the technologies, and we will do some demos to just make sure everyone know how to use the CCIP. Hey, good morning, good afternoon. Yeah, good morning. Okay, so before we start, let me just make a brief introduction of myself. So my name is Frank, and I am a developer advocate from Chainlink Labs. So for those who are not very familiar with the Chainlink Lab, I will give a brief introduction. The Chainlink Lab is a Web3 company, provide a lot of the Web3 services, including the data feed and data stream automation and CCIP. And you can think of Oracle Chainlink as a bridge, just to bridge the data and computing resources from a Web 2 or some blockchain to your smart contract deployed on a specific blockchain. And today we're going to talk about the CCIP, one of the services provided by Chainlink Labs. And the main job of myself is to reach as many developers as possible and help the developers to create your own dApp and participate in the hackathon or start a new project. And if you got any technical issues, maybe you can reach me in the Discord, in the Telegram, or you can contact me directly through the Twitter and the LinkedIn. And I will help you to solve your technical issues. And I will also help you to get whatever you want from the Chainlink ecosystem. Okay, so let's start. So for this workshop, okay, thank you again. Thanks for everyone come to this workshop. And for this workshop, we will have 4 sessions. In the session number 1, we will introduce the CCIP, the Cross-Chain Interoperability Protocol. We will introduce the basics of the Chainlink CCIP and what we can do with the Chainlink CCIP and what mechanism run under hood of this protocol. And after that, we will learn some of the CCIP concepts, the necessary concepts we need to know before we code in with the CCIP. And after the session 1 and session 2, we will complete all the theoretical part. After that, we will have the 2 demos. In the demo 1, we are going to use the CCIP to deploy a sender and a receiver smart contract on the blockchain A as a source chain, and on the blockchain B as a destination chain. And from the sender smart contract, we can transfer some tokens and make this token cross-chain to the destination chain, and we can make a token transfer. And in the demo number 2, we will generalize the cross-chain transaction. We want to send a cross-chain message from the source chain to the destination chain. And by adding some necessary data in our cross-chain message, we can actually allow the receiver smart contract on the destination chain to just execute a transaction and do whatever we want to do. In the demo number 2 in this workshop, what we will do is to send a cross-chain transaction to mint an NFT, which is deployed on another blockchain that is different from your wallet, from your EOA account. Okay, so let's start. First one, the CCIP. So the CCIP is one of the services from Chainlink Labs. And the full name of the CCIP is the Chainlink Cross-Chain Interoperability Protocol. So the cross-chain, as we discussed about cross-chain, it is not a quite new concept. Remember that in the last few years, developers and users from in the crypto industry talking about cross-chain. So many people talking about a cross-chain, so I just want to make sure everyone, when we talk about cross-chain, we are seeing the same thing. So maybe in the very early stage of the crypto industry, when we talk about a cross-chain, we talk about a token transfer from the chain A to chain B, from the source chain to the destination chain. And if you have some token like Ethereum on the Ethereum mainnet, you want to just move your fund, move your Ethereum mainnet, the Ethereum native token from the mainnet to the layer 2 or another blockchain. You want to just move this fund and lock your tokens on the source chain and just send this message through some relayers or some protocols, and then tell this relayer or protocol that I have already locked my token on the source chain, and please just release some tokens to my address on the destination chain. Then you just make a token transfers. And we have a lot of the bridges to help the users to just cross their tokens from the chain A to chain B and from chain B back to chain A. And when the business logic become more complicated, we talk more about the programmable token transfers. By saying the programmable token transfers, which means I'm saying that if you want to transfer your tokens from the source chain to the destination chain, and you want to just send some instructions to allow the someone on the destination chain to execute and manipulate your tokens. For example, if you want to cross your USDC or some other tokens from the Ethereum mainnet to some layer 2 like Scroll or Arbitrum, and then you want your token to be staked on the another blockchain, on the source chain. And you need to just bind the tokens with some following instructions together and send both of them together to another chain, and your tokens can be cross-chain and the tokens can be executed on the destination chain. And this is what we call the programmable token transfers. So by saying this, if you abstract these two types of the cross-chain, you can just imagine that if we can achieve the arbitrary message cross-chain, so it's like if we can send any message from the source chain to the destination chain, we can achieve these two types of the cross-chain seamlessly. So imagine this, when we do the token transfers, what we do is just lock a token on the source chain in a token pool, specifically deployed on the some blockchain. And then we will get some tokens released from another token pool, specifically deployed on the destination chain, so we can cross this token from source chain to destination chain. And by doing this, we actually transfer a message to tell the protocol, to tell the bridge, or to tell the cross-chain infrastructure that we have already locked our tokens on the source chain, and please just give some tokens on the destination chain to my address. If we can transfer this message from the source chain to the destination chain, we can achieve the token transfers. We can achieve the cross-chain message. We can achieve the cross-chain transaction, right? So the Chainlink CCIP is actually a protocol for the arbitrary message. By using the CCIP, you can transfer any kind of the data, any kind of stuff from the source chain to the destination chain and achieve whatever you want to do in your decentralized application. Okay, cool. So yeah, I saw a question asked by Fields. Okay, so good morning, Fields, or good night, Fields. You're asking, does it work for private chains to the public chains? Actually, yes, this can work for the private chain to the public chains. There is some financial institute or bank who has developed something called a bank chain or app chain. They can just create some asset on their app chain or bank chain. And if they want to increase the liquidity of their asset on the bank chain or app chain, they can use the CCIP to relay this token, relay this asset or fund to move them from their own chain to the public chain. This can be achieved. But for now, by using the CCIP, we only support some EVM public chain. So if you want to cross some data from the private chain or consortium chain to the public chain, maybe just send an email to us. We will have someone to help you. Okay, that is a very good question. Thank you. And if you have any questions during the hackathon, during the workshop, please just drop that in the chat box, and I will answer them. Yeah, and next, let's talk about the architecture of the CCIP. So if you have learned any service from the Chainlink, from Oracle, you will know that for the services from the Oracles, usually there are two parts or two domains, the on-chain part and the off-chain part. So for the on-chain part, we will have some contract to just get some requests from the users and then emit an event in the blockchain. The event is like a log in the Solidity. So if the log is written on the blockchain, there are going to be some rows, some infras in the off-chain to just get the request from the on-chain. And then based on what kind of the request in the log, the off-chain infra will do its own job, maybe get some data or do some computing, and then aggregate all the results together and feedback to the on-chain smart contract. So for the CCIP, we'll still have the on-chain part and the off-chain part. But since we are doing the cross-chain, so we have the two of the on-chain part, the source chain and the destination chain. The source chain means that you want to start your message, start your transactions from this chain and send it to the destination chain. And there are going to be some smart contract deployed on the destination chain. Is supposed to be receive your cross-chain message and execute this message in the destination chain. So for now, there are in total 3 domains or 3 parts in the CCIP: the source chain, destination chain, and the off-chain part. So for the source chain and the destination chain, we have several smart contracts like a router, on-ramp, token pool, or off-ramp, token pool, commit store, or MN smart contract. Don't worry, we will explain everything about them in the next slides. What I want to ask them to learn is in this slide is that there are 2 smart contracts, sender and receiver. Only these 2 smart contracts are supposed to be developed by external developers. So if you are a developer and you want to use the CCIP to transfer your tokens or message from the source chain to destination chain, you only need to develop a sender and a receiver smart contract. And everything else is developed by Chainlink. And Chainlink has already deployed the router, on-ramp, token pool, and a commit store, and everything except for the sender and the receiver on the blockchain. You can directly use that. So although the architecture or mechanism is kind of complicated, it is very easier for you to use the CCIP as a developer. Okay, cool. So in order to learn more about the functions of each row, each infra, we are going to next slide to explain what are steps to make a cross-chain message. So the first one, if we want to send a cross-chain message, is called a commit. So as a developer or as a user, you can imagine you want to send a cross-chain message. You need to have a standard smart contract, and then you will write your message and send this message to the router smart contract. In the message you want to send, you will have some chain ID or receiver address and the data you want to send and a token address you want to transfer. You need to have this necessary data within your cross-chain message. And then the router smart contract can wrap all of the information together to create a cross-chain message. And then they will know, the router will know that which blockchain you want this message to be sent and which receiver smart contract you want this message to be executed. And then the router will maybe lock a token in the token pool or do some other transactions and then send all the information into the on-ramp smart contract. And as this message arrives on the on-ramp smart contract, it could be emitted as an event. Like I mentioned before, the event is like a log in the Solidity smart contract. And when this log is emitted, it will be caught by the infrastructure called a committing DOM in the offchain. And a committing DOM is a committing decentralized Oracle network. DON means decentralized Oracle network, which is a very important infrastructure in the Chainlink. And the decentralized Oracle network will get a necessary information from the log and then relay this log to the committing store, this smart contract in the destination chain and with the Merkle tree proof. And this is the step number one, the commit. So in the step number one, you can do a token transfer, you can send arbitrary data, you can just transfer a token plus arbitrary data from the source chain to the destination chain. And once you send this request, there are going to be a committing DOM waiting and keep monitoring the log emitted from the on-ramp and then relay this data from the on-ramp to the commit store in the destination chain. Okay, and when this step is done, we will come to the next step. There is one more thing to be noted. That is called the finality commitment levels. So from this graph, I'm not sure if anyone from you are curious that if there is one scenario happen, it's like this transaction sent to the is sent to the on-ramp smart contract, and it is committed by the committing DOM and related to the commit store on the destination chain. And then this transaction on the source chain is reverted, maybe because the reorganization of the blockchain of the source chain and what will happen in the destination chain. So for example, if someone send me some tokens on the source chain, and then this guy just put this transaction into the on-ramp, and the committing DOM just find these transactions in the on-ramp and then relay these transactions or commit this transaction to the commit store. And when this transaction to the destination chain, I maybe just return back some asset to his address on the destination chain, right? So by doing this, the guy send me some asset on the source chain can do a double spending attack. They transfer some asset to me and I transfer some asset to him in the destination chain, but the original transaction is reverted. So I get nothing on the source chain, but I have already transferred some asset to him in the destination chain, and then I will lose some asset. In order to avoid this double spending issue, we need to introduce another concept called finality commitment levels. The finality commitment levels include 3 status: the latest, safe, and finalized. It is kind of the standard posted by Ethereum official or Ethereum Foundation after the Ethereum merged and transferred from the proof of work to the proof of stake. And it is very easy to understand. So imagine there is a blockchain containing 96 blocks. So they will have the 3 epochs. For each epoch, we have the 32 blocks. And every transactions contained in the block from the block number 1 to the block 32 that is called finalized transaction. The block, the status is finalized, which means the transactions in these blocks is nearly impossible to be reverted because we have 2 epochs as confirmations, right? And every transaction contained in the block from the block 33 to the block 64 is considered as a safe. The transactions will be tagged as a safe, which means the transaction is very, very unlikely to be reverted, right? Because we have the one epoch confirmations after that. And if the transaction is, if the transaction is contained in the block from the block 65 to the block 96, well, this transaction is actually considered as the latest, which means it is possible for this transaction to be reverted. So to avoid the double spending issues, guess which status we need to wait before we do a commit, right? Guess what? Which status? Yeah, maybe someone, maybe you all know that we need to wait for the status to be marked as a finalized, and we need to wait for 2 epochs until this block is marked as a finalized, and then we will do this commit. So when this transaction on the source chain is considered as finalized, the committing DAO will just catch this request from on-ramp smart contract and relay it to the commit store to just in the first place to move this message from the source chain to the destination chain. Okay, cool. And the next one, the second step after the commit is called blast and curse. So the blast and curse is a terminology from the CCIP, and you can just understand it as a certified or uncertified. So it is like this. When this message is relayed from the committing DAO, from the source chain to the destination chain, then there is another infrastructure on the off-chain called RMN. The full name of the RMN is the Risk Management Network. The Risk Management Network will just check the Merkle proof and transaction hash saved in the commit store, which is called commitment, and then reconstruct the Merkle root by all of these informations. And if the Merkle tree root is reconstructed, the RMN will just match if this Merkle root on the on-ramp smart contract in the source chain and the Merkle root in the commit store matches. If the results match, the RMN will send a transaction to the smart contract called RMN contract to see like this commitment is valid and I certify this commitment. And because the Merkle root is Merkle roots match, but if the crypto proof and the Merkle tree root does not match, the RMN will send a transaction to the RMN smart contract to see like there is one commitment in the commit store is not certified, and I will curse that, and there is no execution following that. So this is functions of the RMN, and the RMN is a infrastructure here to make sure the committing DAO is not compromised, right? So if the committing DAO is compromised and relay a false transaction from the source chain to the destination, it can be detected by the RMN. And this is a second step of the CCIP cross-chain message called blast and curse. And after that, we will come to the third one, the execute. So if the transaction in the commit store, the commitment in the commit store is certified or blessed by the RMN, there is another infrastructure called executing DAO. The executing DAO is another decentralized Oracle network, and a different node under the decentralized Oracle network is operated by the different entities. And this decentralized network will check the validity of the commitment in the commit store. And if the commitment is good, the validity is verified, and a committing DAO will just execute this transaction through the off-ramp to the router. And the router will get the necessary data from the cross-chain message, and then maybe release some tokens on the token pool or burn some tokens in the token pool, and then do the following instructions to the receiver smart contract. And the receiver smart contract, which is developed by the external developer, can just write whatever you want in the business logic through some functions in this smart contract to achieve your business logic. And this is this is the whole process of the CCIP cross-chain message to be relayed from the source chain to the destination chain. You can do anything you want using the CCIP to move the arbitrary data from the source chain to destination chain, and it is in the very high security because there are 3 infras off-chain to just relay, certify, and execute. They are operated or run by the 3 different infrastructures in the off-chain. Okay, good. So if you have any questions, just please drop your questions in the chat box, and I will answer these questions. Even if I'm talking about the basics of the Chainlink CCIP. And here is a very quick recap of the Chainlink CCIP workflow. So it is easier to understand the whole process. Like we seen before, this one is a standard smart contract, and this one is a receiver smart contract. And a user can send a transaction through standard smart contract to wrap some information in data and the token related to the instructions together and send it to the router smart contract. And the router smart contract will just get which blockchain you want this message to be sent and which receiver smart contract you want this transaction to be executed, and what data you want to be fetched by the receiver smart contract. And the router will find the right direction and save this smart contract, save this data into the on-ramp smart contract. And after this on-ramp smart contract get the data, it will event an image in the smart contract. And this emit an event, and this event is kind of like a log in the smart contract. And the data saved in the log will be detected by the committing DOM. And the committing DOM will just get the data and put it to the off-ramp, to the commit store. And once the data is saved in the commit store, the second row, the risk management network, will check the commitment in the off-ramp and commitment in the on-ramp to see if the crypto proof matches. And if the crypto proof matches, then the risk management network will just give a certification to the commitment in the destination chain to see this commitment, this transaction is valid. Please execute that. And when this is done, it will come to the phase number 3, and executing down the third one will come to play to just execute these transactions, which is verified successfully in the off-ramp and execute these transactions through the router and achieve the business logic saved on the receiver smart contract on the destination chain. And this is a whole process. Okay, so here a new question. Let me show that. Are there APIs for fetching supported network links data? Yeah, we have some. Actually, that is not an API. It is a document from the Chainlink official website. You can check the supported lanes, and you can check the chain selector and any other necessary data for this blockchain. And I will show you later in this workshop, and we will use that for our demo. Thanks for asking question. Thank you, Enoch. Okay, so we talk a lot about CCIP. So what we can do with the CCIP, what we can do with a cross-chain protocol. And I believe that true innovation is always come from the community. So for this hackathon, I am really excited to see what you guys want to build during the hackathon using the services from Chainlink. And here are some use cases I'm seeing in the market. So that is just something you can consider about to do with the Chainlink CCIP. So first one is called cross-chain collateralization. So for the cross-chain collateralization, which means that you can collateralize your asset on some blockchain. and get some liquidity on another blockchain and do the transactions on another blockchain with the collateralization in your original blockchain. And why we want to do that? That is because some people with a lot of the asset, with a lot of the tokens, want to save their asset in the high security blockchain. But if the blockchain is with a very high security, it is always expensive to send transactions on this blockchain. And you can, with the Chainlink CCIP, you can just stake your asset on the high security blockchain and get some liquidity in the layer 2 and to do the transaction on the layer 2 with a very cheap gas fee. And there is a project called Synthetics, which allow users to collateralize their asset on the Ethereum mainnet, I guess, and get some liquidity in the layer 2 and do the transactions. And another use case might be the cross-chain governance. For the cross-chain governance, think about that you have a very big project, and in this project you have some tokens. You promise the token holders that they will have the right to make a proposal and vote this proposal to be passed or not passed. And if the token holders residing on a lot of the different blockchain, and you need to just collect their vote from the different blockchain, and it will be a big trouble when the number of the blockchain is increasing. So with the cross-chain governance, you can allow the users to just make a proposal in one blockchain and allow the token holders in the different blockchain to vote on this proposal, which is put in a single blockchain. It is a very promising use case. Maybe you can try it in the hackathon. And the third one is the cross-chain trading. So everyone knows that. And the last one is the new kinds of dApp. So by saying new kinds of dApp, I mean you can actually use the CCIP to connect the different DeFi or non-DeFi project in the multiple blockchains. Maybe you can stake your asset on the blockchain A and get some yield on the blockchain B, and make the trade on the blockchain B and get some another asset on the blockchain C. So you can you can consider the different dApp in the different blockchain as Legos, and you can put these Legos together to create your own dApp. So with the Chainlink CCIP, you can just connect all the dApps in the different blockchains together to create your own dApp. Okay, cool. So as I see, the true innovation is always come from the community, and I'm really excited to see what you can do with the Chainlink CCIP in this hackathon. Okay, next is some concepts of the CCIP. So here, the first one is the LAN. The Enoch mentioned earlier, the LAN. And the LAN is just a concept to indicate that you can transfer the token or transfer the message from the blockchain A to the blockchain C. And there is one thing need to be noted is that the LAN is a unique combination of the source chain and the destination chain, which means the LAN from the blockchain A to the blockchain C is actually different from the LAN from the C to A. The from A to C is the LAN A, the C to A is the LAN B. That is a different one. We have this document, the ccip.chain.link/status. You can check all the status of the LANs. For example, we can see the LANs from the Ethereum mainnet. We have the LAN from the mainnet of the Ethereum to the Avalanche mainnet, to the BNB chain mainnet, to the Arbitrum, to the base. And we have a lot of the different LANs, and you can check that on the official documents. And the second definition is called router. So router is like a universal bridge smart contract deployed on the H chain. So for every different blockchain, for the CCIP router, we only have the one CCIP router for the different blockchain. And on the source chain, the router is responsible to just route your message from the A to B, and you need to tell the chain selector and the receiver address for in the blockchain B, and the router can make sure your message can be sent to the right place. And for the routers on the destination chain, this router is this router's job is to help you to execute this transaction on the destination chain, maybe mint an NFT or maybe do something with your tokens on the destination chain, right? So for the routers, that is definitely the smart contract you need to interact from your smart contract, from your consumer smart contract. Okay, the third one is called a chain selector. The chain selector is like a chain ID for the different blockchains. For example, like the Ethereum mainnet, we have these long numbers as a chain selector for the Ethereum mainnet. So if you want to send your message to the Ethereum mainnet, you need to put these chain selectors to the router smart contract. And then the router smart contract will know that the Ethereum mainnet is the blockchain you want your message to be sent. This is just a direction or the ID of the destination blockchain or source blockchain. Okay, cool. So next, the theoretical part is almost done, and we are going to do our demo number 1. For the demo number 1, we will transfer the tokens from the source chain to the destination chain. And before we're doing that, I just want to introduce, we actually have 2 modes of the token transfer, token cross-chain. The first mode is called the lock and mint. So if your smart contract, your token smart contract is deployed in a single blockchain, and there is no other native deployment on another blockchain or other blockchains, and you need to use this lock and mint mode. And if you want to cross your chain from the source chain to the destination chain, what you can do is that you need to lock your tokens on the source chain to the token pool and tell this message to the CCIP. And the CCIP will just mint a token, the wrapped token usually, in the destination chain and drop this token to your address. The wrapped token means that this asset is not the original one. It is another form of the asset, like the BTC and WBTC, the ETH and WETH. W means wrapped. So if you have the token deployed on the source chain and you do not have any other deployments on the destination chain or any other blockchain, you can create a wrapped asset token standard on another blockchain and lock your tokens in the source chain and mint a wrapped token on the destination chain. And if you want to just cross the tokens from the destination chain to the source chain, actually what you need to do is burn this wrapped token on the destination chain, and a native token will be unlocked on the source chain. And that is a whole process. And yeah, hello everyone. Yeah. So use case for this one is, like I said before, the token minted on the single chain. For example, the Chainlink token, and a token with encoded constraints. For example, if there is no function called burn and mint in the deployment on the source chain, you need to lock this token or unlock this token when you want to transfer in or transfer out these tokens. And the second mode for the token cross chain is called burn and mint. And for burn and mint, that is more easier to use, because actually for the burn and mint, you will have the smart contract of your tokens deployed on multiple blockchains. On the source chain, if you want to cross-chain your tokens, you can burn this token on the source chain and call the mint function on the destination chain and get the token in your wallet. And if you want to cross the token back from the destination chain to the source chain, you just burn the token on the destination chain and get some tokens, mint some tokens on the source chain. It is pretty straightforward to understand. And the use case for this is for the tokens that are natively minted on multiple blockchains. For example, like USDC. For USDC, the smart contract of this token deployed on multiple blockchains. And for the average deployments, there is a function called mint, and there is another function called burn, and you can call this burn and mint functions to just cross this chain to the chain A to chain B and back forth. So the advantage of the burn and mint is that you need to create a token pool. You can directly interact with a token smart contract to do the cross chain. So for this, for today's demo, we are going to use the burn and mint mode. We will use a token that is created from the Chainlink to demo this token cross-chain. Okay, so in order to allow you to get some information from me and to do this demo, to code along with me, I create a result pad here. I will put some necessary information in this result pad. So if you want to get the codes or get the configurations, you can directly copy the code here and paste it in your MetaMask, not MetaMask, in the remix, and follow with me. And I will just write it in the, I just write it in the chat box. And you can copy that and enter this document and copy what you need to follow me. So let's just start the token number one, the demo number one. So in the demo number one, what we are going to do is transfer the token called CCIP BNM. The BNM means burn and mint. We will transfer this token from Avalanche Fuji to the Ethereum Sepolia. So how we can do that? And if we want to do the Solidity coding, we usually use an online IDE called Remix. And you can just create your smart contract and compile and deploy your smart contract through the Remix. And by using this, you don't need to worry about all the configurations and the stuff behind the scene. And you can directly write your smart contract, click the button, and deploy your smart contract on any blockchain, which is configured in your MetaMask. Okay, so for the Remix, I will copy that link and paste it here. This is a Remix, and you can go to the Remix. And in the Remix, we are going to create a new workspace. Click this 3 lines and create, and we can choose a template. For this workshop, we are going to use a blank template, and we give it a name called Chainlink Workshop. CCIP, maybe. Yeah, and click button OK. And then we will have a file explorer. You can see there is nothing in this file explorer, and we need to create files under this file explorer, and we will see the files in the editor here. And the first smart contract we want to create is this one. I have already put the code in my gist, and I will paste the link here so you can directly go to this one. The first one we received in this gist, that is called the source chain standard. I will copy everything and paste in the Remix and explain everything. Copy everything and paste here. Maybe we give it a name called source chain standard.solidity. And actually, you can name it whatever you want. I just name it a source chain standard.solidity. And click enter button, and we will see here we have the editor. And in this editor, we can write our smart contract. And paste it here. There is an alert popped up. That is because the Remix detects that we copy everything, and Remix just want let us know that we know what we are doing, and we know what we are doing. So click OK, and oops, here is a double slash, and click the command plus S or control plus S to compile this smart contract. And because we use 0.8.25 as a version of the compiler, so there is an error. We can switch to the 0.8.19 to use this version of the compiler and compile that again. You will see the little green check mark here, and then we have our smart contract compiled successfully. Okay, so within this smart contract, I will introduce some very useful information. So for the first one, we will see this function called send message pay link. This function is used to send a cross-chain message from the source chain to the destination chain. And when using these functions, we will pay link token as a gas fee. So you need to pay the fee to the Chainlink if you want to cross any message from if you use any Chainlink service, including the CCIP, you need to send a cross-chain message. You need to pay the link. And here are the parameters we need to input. The first one is the receiver. This is a smart contract we see here, the receiver. We need to tell the CCIP which smart contract we want our message to be sent. So we need to give it a receiver smart contract. And next one is the text. So except for transfer tokens, and we want to also transfer some data. And we can write whatever we want as a text, and this data can be transferred from the source chain to the destination chain. We can check if we get this data on the destination chain later on. And then we need to give the address of the token, which means which token we want to transfer from the source chain to destination chain. And we need to transfer this token, the BNM token. I will show you where to get the address of the BNM token later. And then we need to tell the CCIP how many tokens we want to transfer in this message. So these are 4 parameters we need to input in the send function to tell the CCIP which data, which token, and which chain, and what is the address of the receiver. So the router can just route our message to the right place. Okay, so let's see what's in this function. So first one is we need to create something called a token amount, and we will save the token and the amount in this struct. This is actually an array because we only have one token, so we only create a string with one element, and save this element in the index 0. It's the first index, and we will save our token address and how many tokens, the token amount we want to transfer in this struct, and then we can build a EVM to any message. So as I call that an EVM to any message, it means that we can support the cross-chain message from the EVM chain to the non-EVM chain. So we call it any. But actually, for now, we only support EVM to EVM. So we can understand it as the EVM to EVM message. But in the future, we will have the support for the non-EVM chain. So in order to build a EVM to any message, we will use the client.evm message and input the data we input here, this data, and also the struct we instruct here, and we put everything under this EVM to any message, like a receiver, smart contract address, and the data we want to transfer, and how many tokens we want to transfer, and another extra arguments, which is a gas limit we allow the CCIP to use on the destination chain to execute our transaction. And the last one is called a fee token. So as I said before, there is 2 options you can pay the fees when you want to use the CCIP. The first option is that you can pay the link token. And another one is that you can pay the native token. So if you want to pay the native token, you just keep this as a 0, the non-address. Then you can use a native token to pay the cross-chain service fee. Okay, so for now, you have already created EVM to any messages successfully. And after that, we need our router smart contract, because the router smart contract will help us to route our message to the correct place on the destination chain. And we use interface and router address to create a router handler to help us to call the functions within the router. And you may wonder where this router address come from. I just write something here. This is hard-coded because this smart contract is only used to transfer tokens from Avalanche Fuji to Sepolia Ethereum. So if the smart contract you want to use is supposed to be deployed on another blockchain like Arbitrum Sepolia or some Polygon Amoy, you need to change this hard-coded information. And for now, for simplicity, I write this information here, hard-coded here. So if you want to see all these supported chains, here is a place you can check that. The docs.chain.link. This is official documentation of the Chainlink services. In this documentation, click this CCIP. Click that, and it will direct you to the documentation of the CCIP. And under the supported network here, let me zoom in. Here is a supported network, and it will have the 2 types of the network, the mainnet and a testnet. And for now, we are using the testnet. Click that one. You will see all the lanes. So maybe just click this one, collapse that, the lanes on the Fuji testnet. It includes all the chain. The message can be cross-chain from the Fuji testnet. So for now, we are using this one, the Fuji testnet to the Sepolia testnet. Right, this one. So you can check the CCIP BNM token address LNM token address and some other tokens that is supported by CCIP to cross-chain in this LAN. And except for that, you will also find the router address here. So if you want to build your own CCIP applications, you can find the router address under this page, and also the chain selector, as we talked before, that is ID for the Fuji. You need to tell the router smart contract this number if you want to send your message from your blockchain to the Avalanche Fuji. Okay, and these are the fee tokens you can pay in the Avalanche Fuji for the CCIP fees. So for now, what I need to know is this router address, and I have already hard-coded here. If I paste it here, you will see these are the two same values. So we have the router Avalanche Fuji, and we have the link token address, and we have the chain selector for the Sepolia because we want our tokens to be cross-channeled to the Sepolia testnet. And with all of these configurations, we construct our EVM to any message, and then we create our router. And after that, we need to check if we have enough balance to pay the fees. So we use the router.getFee to estimate how much money will be costed if we send this cross-chain message and get this estimation. And then to check if this estimation is smaller than the balance of the link token in your smart contract, in this standard smart contract. If this fees is greater than the balance of this smart contract, the transaction will be reverted. And if everything is good, we will approve that the routers can use the link tokens in your smart contract, and the router will is able to use the amount of the tokens you want to transfer. Because you want this token to be transferred, you need to allow the router to just have the right to use your tokens. And then call this function, the router.ccip, and send this EVM to any message to the Sepolia. We just give it the chain selectors. And this is the function to send the cross-chain transaction to transfer your tokens from the Avalanche Fuji to the Ethereum Sepolia. And since we already have our source chain sender, we also need a receiver on the destination chain to receive the data and the tokens you send from the source chain, right? So we can go to this file, and I will paste the link on the reset pad so you can see the code, the receiver smart contract. And I will paste it here. Oops, sorry. Oops, sorry. I just used that wrong shortcut, and I will paste it here. And this one is a sender for token transfer. And this one is a receiver for token transfer. Okay, let me check the code here. Go to the gist and paste it here. You will see the receiver smart contract. And as before, I will copy everything and paste it on the remix, and I will explain everything about that. Go to the remix and click this one, the file explorer. And then we create a new file here called the destination chain receiver.solidity. And you can name whatever you want. I just use this name to clarify this smart contract is used to receive the message and the tokens on the destination chain. And paste everything here. Oops, why we have this one? And compile that. You will see the little check mark here, and that means that the file is compiled successfully. And in the receiver smart contract, what we need to pay attention is this function, this one, the CCIP receive. And the CCIP receive is a function to receive the data you transfer from the source chain to the destination chain. And you can see here, we have a parameter called any to EVM message. Remember, in the source chain sender, we have the message called EVM to any message. And when this message is cross-channeled to the destination chain, we will have this parameter called any to EVM, which means that this message, it is unknown to the receiver which blockchain this message is from. But for now, the message must be from the EVM chain. So this also is an EVM to EVM message. But we will in the future to support the non-EVM blockchain. So we call it any to EVM message. And in the EVM message, we will get the message ID, the data, and decode this data with a data type string and save it in the attribute called last received text. And we will also have the token and a token amount and save this data into the smart contract. And we can also check the balance of the smart contract to see if the token is the number of the token in this balance is increased or not. So we can use this function to check our token transfer successful or not. And another one is you can see that the destination chain receiver extends inherit from the CCIP receiver. That is also the reason why this function, the CCIP receive, is internal, because there is another function called CCIP receive that is written in the CCIP receiver in this smart contract. It is used to be called by the CCIP, and the CCIP receiver will call the function underscore CCIP receive to just pass the value into this function to do whatever you want to do. But for now, we just simply save this data into our attributes. Okay, cool. So for now, we have already complete our receiver and sender. So next, we will deploy this smart contract and send our cross-chain message. And first, I need to switch this. What is that? First, I need to switch the environment from the Remix VM to the injected provider MetaMask. Click this one. Yeah, when you see the item here is shown as the injected provider MetaMask, that means the Remix will use whatever you configured in your MetaMask as a blockchain environment, and you will deploy, transact, and interact with your smart contract in the blockchain network you configured in your MetaMask. For example, in this one, you will have the Avalanche Fuji as the blockchain environment. And if in your MetaMask you do not have this configuration, there is a very easy way for you to add a network into your MetaMask. Go to a website called chainlist.org, this one, and I will paste it here. This one, go to this website and input Fuji. And click this check, you will see that here is a blockchain called Avalanche Fuji testnet. And if you do not have this network in your MetaMask here, I mean, in the top left corner of your MetaMask, and then you need to click this button to add to MetaMask and switch to this testnet from your current one. And then you will use the Avalanche Fuji to deploy and interact with the smart contract. Okay, cool. And if you do not have some tokens, the test tokens, like the Avalanche token, Link token, and the CCIP BNM, the first step is that you need to go to the faucets.chain.link. I need to copy this link and paste it here. Okay, just go to this link. That is Chainlink faucets to allow you to get some test tokens. Right? If you do not have the test tokens, go to this website, and as you can see here, you can check this check mark and log by the GitHub and click this send request. You will get some test tokens from this faucet. And once you get some tokens, you can send transactions on the Avalanche Fuji. Okay, so back to the Remix. We want to deploy our sender first. compile that, make sure the smart contract's name displayed here. Because if you have a multiple smart contract, maybe the smart contract displayed here is different from the smart contract you want to deploy. So make sure the correct smart contract is here. And then click the button, deploy, this orange button. And when your MetaMask popped up, and click confirm. Then maybe you wait for several seconds, you will see a new smart contract showing here under the deployed on-chain smart contract that is called a source chain sender. And you will have some different functions. You will know some are the orange and some is blue. That is because if you want to just change the status of the blockchain, and the functions will be orange. And if that is only the functions to view some data on the block, that will be the blue. So this is a function we are going to use to send our data and tokens from the source chain to the destination chain. And the receiver, text, and a token, and amount. And we will have input these parameters later on. But for now, we need to deploy our second smart contract called a destination chain receiver. And let me switch our MetaMask network from Avalanche Fuji to the Sepolia. Here, for now, we have the Sepolia. This one is a default testnet provided in the MetaMask. And you need to switch on the show test networks if you cannot see this network under your MetaMask. And when we switch to the Sepolia, and then compile this again, and go to the deployment button, this tab here, and you will make sure the destination chain receiver deployed here, and then click the button deploy. And the MetaMask pops up, and like before, we confirm our deployment transaction. And maybe after several seconds, we will see another smart contract showing here. The transaction is a little bit slower in the Sepolia compared to the Avalanche Fuji, because that Sepolia testnet mimics the features of the Ethereum mainnet, so it is a little bit slower. But finally, we get this, the destination chain receiver. And for now, we can send our cross-chain message. But before doing that, one thing you need to get is in the documentation, go to the guides and go to the last one, the acquire test tokens. You need to get some CCIP BNM tokens. And for this one, just change the network to the Fuji testnet. Like it requires you to change the test network on your MetaMask. Click this one, switch network. And then you can just mint one CCIP BNM token. Because I already have one, I think. Yeah, I have 1.97 CCIP BNM, so I will not mint one more. But you can just mint a CCIP BNM token here if you do not have this token. And if you cannot see this token under your token list, just use this button, add CCIP BNM token to the wallet, and the token will be added to your token list under the MetaMask. Okay, so get a CCIP BNM token, and I will just copy this link to the resub pad. So add token to your token list and mint one. Yeah, and add BNM token to your token list and mint one. Here. Okay, so when you get a BNM token, so back to the remix. So for now, I am on the Avalanche Fuji. Don't forget to switch the network from Sepolia to Fuji. And then go to click this source chain sender smart contract, and click this one. We need to input these 4 parameters under the function send message pay link. The first one is the receiver smart contract address. So we can get address here. So click this button. We just deployed before. For the destination chain receiver, click this button to copy the address and paste it here. And in the text, we can just randomly input something, maybe hi there from launch Fuji, type whatever you want. And then we will give it a token address. The token address is what we added here, the CCIP bname. And we can get a token address here, the token details. It will give you a token contract address and input it here. And if you don't want to get the token address there, you can also have the token address in the mainnet, testnet, and under these configurations, you can find all the related addresses. In the testnet, go to the links on Fuji, you will see the to the supported testnet, you will see the CCIP -bname token address here. It's D213. Let me check if we have the same address, D213. So the same thing. And we also need to input the amount of this token we want to transfer. So because we want to transfer one, but and we input one, but we cannot just simply input one. We need to input 1 plus 18 zeros because we cannot use the floating numbers in the solidity. So we are using a lot of zeros to indicate how many tokens we want to transfer. We will have the 1, 2, 3, 4, 5, 6, 7, 8, 9, and copy paste. So for now, we have a 1 and 18 zeros. And for now, if we click this button, transact, there is an error called a gas estimation failed. That is because we do not have enough balance to pay the CCIP fees. So we cancel that and transfer some links to our source chain, destination chain, source chain sender. And click send, paste the token address here, smart contract address here, and go to the link. And we give like 5 links to our smart contract. Click next and confirm. And I think we forgot to transfer some BM tokens to our smart contract either. So I need to send and paste our smart contract address here and click the drop-down list, click the CCIP bname. And we want to give the 1 CCIP bname to our smart contract. Click next and confirm. Okay, so this transaction is pending and we need to wait for several seconds. So for now, all the transactions is confirmed. So for now, our smart contract have some link balance and have some BNM tokens balance, and we can send this cross-chain message. Click this button, transact, and your MetaMask pops up, and click confirm. So for now, we have sent our first cross-chain message to transfer some tokens from the source chain as a Avalanche Fuji to the Sepolia as a destination chain. And when this transaction is sent, you can just go to the activities and click this one and copy the transaction ID and go to another website called ccip.chain.link and paste your transaction ID here. Let me just copy this one and go to the result pad and check the status of your cross-chain message. This is the CCIP Explorer. So every time when you have the cross-chain message, get the transaction ID and check the status of this message on the CCIP. So you can see here, we have the messenger ID, we have the source chain hash, and we will have the destination chain transaction hash because this message has not been crossed. So when this is committed, we will see the destination transaction hash. And this is the status. So for now, the source chain is finalized. That means the transaction, the block which containing our transaction is considered as finalized. And the committing DOM has already committed this message to the destination chain. And we are waiting for our RMN to bless or curse our transactions in the commit store. And next, we have information like a source chain and like a destination chain. And we have the timestamps for our transactions. You can find nearly everything about your cross-chain message under this page. And for now, it is committed, right? So when the transaction is finalized, it is committed by the committing DOM. And for now, we are waiting for blast occurs. Okay, so is everyone following? Do you have any questions about our token transfer demo? Like how the security is promised and questions like that? No? Yeah, that is very good. That seems like it is the process is straightforward and clear. Okay, so usually it will take about 7 to 8 minutes to finish this cross-chain, and and when everything is done, we will see the tokens on the destination chain, and we can check the balance of our destination chain, and we can check if we get the message on the destination chain. And for now, let me just check it to see the current status. If you want to interact with a smart contract deployed on the Sepolia, don't forget to switch your network on the MetaMask. So I switch to the Sepolia for now, and then I can go to our second smart contract, the destination chain receiver, and we can call the BNM token. It will give me the address of the BNM token on the Sepolia, and we can check the current balance. That is, it is 0. And we can check the latest receipt, and you can see the message is the receipt is empty. So the empty for message ID, and empty for the text, and empty for the token address and the token amount. And when the cross-chain message is done, we will see something here. That means the data is transferred from the Upbound Fuji to the Ethereum Sepolia. Okay, let me check the status again. It is still committed. So if you do not have any questions, I think we don't need to wait for a very long time. We can just continue our workshop, and then I'll get back to this status when it is done, maybe after 5 minutes. So this is demo number 1, and next we will do the demo number 2. In the demo number 2, what I'm going to do is to transfer some app tree data from the source chain to the destination chain, and I will add all the informations that is necessary to mint a NFT on the Sepolia to this cross-chain message. And after this data is transferred from the Fuji to the Sepolia receiver will help me to mint a NFT that is deployed on the Sepolia testnet. Okay, let us check what we will do in the architecture. So as we said before, we have the sender smart contract and the receiver smart contract. But for this example, we will have one more called USD721. The USD721 is an NFT smart contract. So what we are going to do within this demo is we will wrap some information in the sender smart contract and send this message to the router. Router will help us to route our cross-chain message to the correct place, to the right place in the destination chain we specified in the receiver smart contract we defined in our message. And once the receiver receives our message from the Fuji, it will execute this transaction to call the mint function within the NFT smart contract. And a NFT will be minted on the behalf of my address. And after that, the result is that you send a transaction on the Fuji, and an NFT on the Sepolia will be minted under your address. And we will do this in this demo. So let me see if the last one is finished. Oh, still committed? Come on. Okay, anyway, let me just start the second one. So before we doing the second one, I will copy the address, the link into the resub pad. You will see the smart contract. So this one is for the NFT smart contract, and I will paste it here. And this one is a smart contract for the standard, and I will paste it here. And the last one is the receiver smart contract, I believe. Let me paste it here too. This is NFT smart contract. This is a sender contract. And this is a receiver contract. And all these 3 smart contracts is for the demo number 2. Okay, let me check this again. It is still committed. It's already 7 minutes and 45 seconds. Okay, whatever. Let's start the demo 2. So in the demo 2, we still need to create some new Solidity smart contract. And the first one, we need to create a my NFT.solidity. This is for our NFT smart contract, USDC71. And let me open that in the NFT smart contract in this link. Go to this one. And I will copy everything like before and paste into the remix. And then I will explain everything, paste it here. And for this smart contract, you can see that is a very simple smart contract inheriting the USDC701 from the OpenZapchain. OpenZapchain is a company providing some very safe and very safe and necessary token standard. And you can just use your token standard and add some custom logic based on that. And you can create your NFT or some other token standard in a very fast way. So we are inheriting the OpenZapchain USDC701 and the USDC701's URL storage, which allow us to add some metadata into the NFT. Because when you see the NFT, you will see the picture, you will see the GIF, and that means there is something called metadata behind our NFT. And this is the metadata we saved behind our NFT. And in the constructor, we will give the name and a symbol to our NFT, my NFT and MNT. And this is a function we will call to mint our NFT. So we will first give the token ID, and then we just mint this address, this to address with the token ID. And second, in the third step, we are going to assign a metadata URI to this token ID and make this NFT to be recognized or to be viewed by the ordinary users. And this is a function we can use to mint the NFT. Okay, let me compile that. Everything is good. Go to the Sapolia. Yeah, in the Sapolia. And we want to, let me deploy that later on and finish the second smart contract quickly to deploy them all in one. Go to the second smart contract, that is a sender smart contract. And actually for the sender and the receiver, we don't need to copy that. It's pretty same as the sender and the receiver we have just used for our first example. Transfer tokens, because if we want to transfer some arbitrary data, we actually still use the same function to send some data from the source chain to the destination chain. So we just need, before doing that, let me check the result. Yeah, it is a success. So for now, the cross-chain is finally finished for our demo number 1. In the demo number 1, we transfer the tokens and the data. And for now, after the like 10 minutes or 9 minutes, the cross-chain message is done. And let me check the result of the first demo. The first one is a destination chain receiver. And we can just check the balance again here, current balance. You will see it is a 1 and plus 18 zeros. That means the balance of the CCIP, the balance of the token CCIP BNM is 1 for this smart contract for the receiver. And if we click this button, get latest received. And the latest received have the 4 parts. The first one is the messaging ID, that is something here. And the second one is a string. It is just the string we typed here, the hi there from the Avalanche Fuji. We can see that the data is saved here, the hi there from Avalanche Fuji. And the second one is the token address we transferred and the token amount that we transferred. So that means the data and the token has already transferred from the Fuji to the Sepolia within our through the CCIP with the use of the sender and the receiver smart contract. Okay, cool. That is the first demo, and when that is done, we can remove this deployed smart contract here, and we will go to our demo number 2. As we said before, we can just modify our source chain and destination chain if we want to just send a data. So for the first one, we want to modify our source chain sender. We will still using the same contract for the demo number 2. And the first one we want to change is that because we will not send any tokens for the demo number 2, so we don't need this one, right? We don't need to any information about the tokens. And oh, not this one. We don't need to add anything to this contract, and we can keep it as a 0. So that is an empty array, and we pass the empty array to the token amount. And for the next one, we keep it the same, and the receiver, we keep it the same. The data, we also need to change. We don't want to send anything like a hi there or hello world. We want to use a function call. So what the function we want to call is a safe mint, this function, right? So I just copy that, go to the source chain. I want to encode this one, the safe mint address. So the way to encode that is to use the environment variable called abi.encode with signature. And add the safe mint here, add a double colon, and then give the value of the parameter. The value is a message.sender. And click this one and remove that. Okay, so for now, we just input another thing under this arbitrary data. And because we use something else, we do not need these 3 parameters. We only need the receiver. And compile that again. And because we have some comments here, so we need to remove that too. The receiver, only keep the receiver and remove everything else. And still, we have some errors. Let's see what is that. Oh, here is we need when we transfer the tokens, we need to approve the router to have the ability to use our tokens, because for this demo, we don't need to transfer any tokens. So we remove that, compile it again, and everything is good. So for now, we can just use this sender to transfer not token, but data by encode with signature to encode this function call and add it to our cross-chain message. And after this is done, we switch back to the destination chain receiver. In the destination chain receiver, we will change that the CCIP receive. In the CCIP receive, we don't need to we don't need to use save this message. We need to call the NFT safe mint function, right? And how we can call that function? Actually, if we want to call another function from another smart contract, we can just create a handler. And in order to create a handler, we need to interface and INFT and give it a function. The function we want to call is this one. So we copy this line and go back to the receiver chain and paste it here. And we give it a semicolon. And because in the interface, we can only use the external. So we change that to the external and compile that. Oops, there's something wrong. Oh, for this one, we comment that for now. So for now, we have already created a interface within our smart contract. And then we need to give create an attribute based on the INFT. So INFT public and NFT. So if we have this NFT, if we want to use that, we need to instantiate this NFT with the address. So in the constructor, we will give the address at NFT address. And within the constructor, we can just instantiate the NFT with the address input in the constructor, the NFT address. Okay, till now, we have the handler of our NFT. And within our CCIP receive, we will use the address to get the NFT's address and call the SafeMint functions. So how we can call the SafeMint functions? That will be from the NA2 EVM message. From this one, we will have something like data. So remember that in the source chain, we save this one as this one. The ABI.encode with signature give the signature, which is a function name, and the value of the input. And we encode that into a bytes. And then in the destination chain, we'll get this data and call this data to the NFT smart contract. And actually, there are going to be two return values. The first one is a Boolean value to indicate if this function call is a success or not. And the second value will be the return value of the function, because we do not have any return value from this mint function. So we just make it empty. And then we can require this one should be success. And if that is not successful, we will give the error like mint failed. So for now, we have complete the CCIP receive function. So the CCIP receive function will just call the NFT smart contract and mint a NFT for us. So that is a whole process. And for now, I think we can deploy all the smart contracts and see if that works. So for the source chain sender, we modify here. Destination chain, we modify here. And we also have a my NFT. And cool, we go to the supporter first. And we compile our NFT smart contract. And then we go to the deploy. Just click this button, deploy. Confirm. And there is one way to check our NFT in the OpenSea testnet. Go to the OpenSea testnet. We will see our NFT in the OpenSea testnet later on. Let me go to the profile first to see if I have anything. Nothing under my profile. So after this NFT is deployed, and we can deploy our receiver. So click this destination chain receiver, compile that, and make sure you have this destination chain receiver and get the address of the NFT and put it into the constructor and deploy that. The MetaMask pops up, and click confirm to deploy this smart contract. Okay, so second smart contract deployed here. So if you want to test if this mint function works, we can just call the functions here from the CCIP receive, or we do not have that one. Okay, anyone? We just use this CCIP receive to be called by the CCIP, and then next we are going to the Avalanche Fuji in the MetaMask to deploy our sender. Select this one, Avalanche Fuji testnet, and switch to the source chain sender and compile that, and click deploy. Deploy this one. Yeah, we will see the third smart contract. And in this smart contract, we will know that we need to send this message, and this message this is functions send message pay link. We only have one parameters because we remove the other three parameters in our function. So for now, we only need to input the address of our receiver here. And we need to click this button to send the transaction. But before we do that, we need to transfer some link tokens to our smart contract. Copy the smart contract address and paste it here. Go to the link and maybe give it 5 links. Click next and confirm. Okay, the transaction is confirmed. And then we can just click this button to transact, to send our CCIP transaction, and to send the function we want to call, the receiver address of the smart contract we want to call, and the chain selector we want our message to be sent, and click confirm. And as before, we can go and get this transaction hash by clicking this one, or copy transaction ID, and go to the CCIP. This is a transaction we made for the first demo. And in the second demo, we will have this one, and enter that. So the same thing happens. We will see the status of this cross-chain message from the message ID, the source chain hash, and the destination chain hash, and the status is we are waiting for this transaction to be finalized on the source chain. And after that, we can just commit it. And then blast occurs, and finally, we need to execute that. And this is a timestamp. Actually, what left is the rest is we need to wait for this cross-chain message to be done by the CCIP. And it will cost about 10 minutes. And so for now, the demo is almost done, unless you want to wait 10 more minutes to see if the result is good or not. But for now, I have something else for you. Here we have some references. Because the CCIP is a very important project from the Chainlink labs, so we have a lot of the different materials you can learn about CCIP. I will paste it here. We have the documents I have already shown you in this workshop, and we have some examples. Let me open that in the GitHub. Yeah, you will see some demos under this repo if you want to find some sample code to develop your dApp, and you can find examples here. And we also have some master classes for the CCIP. So if you are interested in what is actually running under the hood, and you want to learn more examples from the CCIP, you can go to these 4 master classes. Let me go to the first one to show you what in that. So this is the first one, the CCIP interoperability problem, and it will introduce the learns and well, here Patrick, and the solution. And for here, you will see the exercise number 1, the transfer tokens, exercise number 2, the transfer token and the data. And if you want to do something like that, you will find all the sample code in the master classes. And it also gives you the architecture in depth to allow you to understand more about the CCIP. Okay, I think that is pretty much what I want to show you in this demo. And thanks for everybody's time. Thanks for participating in this workshop. And let me check if the status of this cross-chain finalized. Yeah, it is still committed. So does anyone has any questions? Please drop the questions in the chat box, and we can talk about the CCIP, talk about the technology, maybe talk about more about Oracle. And maybe if you want to ask something about your project, how to get a reward, how to be a winner in the hackathon, please just chat in the chat box. And I'm really excited. I really want to talk with you. And GM everyone from Orlando, Florida, USA. Yeah. Good morning. Yeah, good morning. I love Florida. Okay, so no questions, and we still need some time until the transaction is done. And actually, I'm not sure how much time we need to wait, maybe 10 minutes, maybe 5 minutes. And after this time is done, you can go to your OpenSea and you will see there going to be a new NFT showing here. That NFT is on the Sapolia, and actually the one who mint this NFT sent the transaction from the Avalanche Fuji, and you will see the NFT here. And I think we need to wait for 10 minutes. And yeah, I don't think we need to waste this time because that is all the coding part is done, and what we only need is to wait for this cross-chain message to be done. You know, the time is really depends on the how much time is used when we wait for the transaction to be finalized on the source chain, and it really depends on that. Yeah, and if there's nothing, I think it is almost done. From that is pretty much I want to show today about the CCIP and the Chainlink. And yeah, thanks for everyone's time. And if you want to find the code sample smart contract I'm using today, just go to the result pad and to go to the link I pasted here, and you will find everything. And also use the Chainlink official documentation to check everything you need. And if you want to talk with me, you can reach me at a Discord and a Telegram, and you can also just talk me on the Twitter and LinkedIn, whatever you like. And thanks everyone for your participation, and hope you have a very good rest of the day. Okay, bye everyone.